Hello, my name is Todor Vasilev, and I start my video demonstration of the OOP assignment 2. And on the left hand side I will have the form, and then here I will have the Eclipse open, and in this corner I will have the application running. So I've already started putting some details on the form just to save some time with my email, names, student ID, and my CS4D group with Duncan. So I understand that I must provide a YouTube video, and the requirement one is basically making sure that the LBUGraphics.jar file is properly added to the project. So here's my project in Eclipse, Todor Graphics, and inside I have my main package which contains my main file and the rest of the classes, the main class and the rest of the classes that I have. And here I have imported the LBUGraphics.jar as per this point. Also I have additional images. So the next one, project contains MainClass.java that sets up the LBUGraphics correctly by extending the LBUGraphics. So I have the graphics system class file, which basically extends the LBUGraphics file, and I've declared it as an abstract method because I don't have the abstract method. I've declared it as an abstract class because I don't have the abstract method in this class. Then this is followed by the commands class, which is also extending graphics system, that extends the LBUGraphics. And here I have the abstract class process command, which is mandatory for this project. And then the main class basically creates an object that calls the constructor of the commands class, which is basically extending the LBUGraphics. So following by correctly call the LBUGraphics about method, and the turtle animation is displayed, show your code, and then show it running. So what I've done is in my commands class, in the process command method, this is the method which processes all the commands that are inputted by the user as a string, started as a string, which is getting split by if there is any space between the words of that string, and they're getting saved in this array called my array. And then I further do some validations for if these elements are strings, or some of them might be integers, and then I check against a list of commands which start from here, 184, and then I use if and if else statements to check against each one of these commands. So they're alphabetically ordered, so the about method should be the first one. And here is the way I check them. If I have only one command written, and if that's about, then the clear method gets called, then the reset, and then the about method gets called. So if we run the program now, let's put it in this corner and type in about, and we get the turtle drawing doing the dance. So this is working correctly. MainClass.java has a main method which creates an object of graphics system. I've already shown that, and this is how it works. So also I've got calling the constructor of commands class, which is this method here, special method, and that is basically creating an object of this method, my graphical user interface method, passing this into this method that I've got as a drawing panel, which is creating the LBUGraphics drawing panel, and then it creates the rest of the mainframe, which I've called it mainframe, for this application to run. So that is working as well. The about method is called and the OOP animation appears, then the user types about. Right, we've done that, we've showed it, and in your code show that the turtle animation in response to typing about. Yeah, so that's okay. Requirement 2, PenDown command working. We'll see if it works. Right, showing your code. So the PenDown command is, if we go to the P commands, there's a pen. So here are the pen commands for PenUp, PenDown, and also setting the color. So we're making sure that the commands start with pen, which is the first element of the array in my case, and then whether there's any other parameters as an argument, depending on what the program will do. So if there's only one, if it's just pen written, we're displaying missing parameter. And then if there's two parameters, pen plus something else, whether it's a color, red, green, blue, black, white, yellow, then it will call any of those methods, set pen color, and then displaying the message. The pen's whatever color we set it to. Also, if we call PenUp, it will call the PenUp method, and if it's PenDown, call the PenDown method. So just to show it, we're going to say what was that? PenDown. So pen down. Now, before we press OK or Enter, we can see that this image here in this corner indicates whether the pen's up and down in live while the program is running real time. So at the moment the pen's up, so if we press the PenDown command, so the pen goes down, the image has changed, and if we type forward, forward, and the pen is now drawing, so the pen is down. Forward command works, we've just shown that as well, and showing your code that show the turtle moving in response to the user type forward. So the forward command, just to show the code, go back to the F forward. Here we go. If we have just the forward word without any other parameters, again we display the missing parameter and we call the forward with a default value of 40 in this case, which I've put in. If we call forward with a parameter, so basically if we have something else, then we're checking what exactly the parameter is, and then it can do different stuff like we see here from the code. And we've got some quite complicated validations for that depending on what we've entered. So for example, we say forward 10, just because we're quite at the edge now. So the turtle goes forward by 10 pixels. Previously we saw if we just type forward, in this case it will not. Oh yeah, missing parameter, default forward code. Right, so that works. Forward command works with a parameter. We've already seen that as well with forward 10, so that's working as well. We've seen the code for that. Backward command works, so if we type backward, and the turtle goes backward by default parameter as well. Now if we see the code for backward, basically we're using the forward method but with a negative parameter. So whatever the parameter is, we just put a minus in front of it, and basically the turtle goes backward. But obviously we can't just put forward minus 40, because this will not work. It says invalid parameter, so we can't have a negative number for a parameter. So yeah, that's how the backward works. And that works fine. So backward works with a parameter. So if we type backward 100, so this is the front of the turtle. If we press enter, the turtle just goes backward with 100 pixels. So that works as well. We've seen the code. Turtle left command works. So show the code. So if we go to I've got this, I think there's just left, is it, or turn left? Just hold up. Pen is down. Right, I have, just because it's been so much, if I press help, I can see all the commands I've got. So I've got it as a left only, so it should be on the else. Load. Okay. And where is it? Got the load pen color. Save triangle. Turn, yeah. Okay, so we've got turn left. So I'm using the left, actually the left word for that. So what I'm doing again, if it's just left without any parameter, we display the message missing parameter, and we just turn left, which is a default 90 degrees left. If we have a parameter, then we run this part of the code, which is turning left, passing an integer, because parameter 1 basically is an integer. If we look at this part of the code, we've got parameter 1, 2, and 3 as integers, and the way we are actually passing the string parameter information to this integer is by this try and catch statement here. So we try to pass the integer, the string, sorry, to an integer, and if it is successful, then we assign that to the parameter 1. If it's not successful, then we assign parameter 1 to be equal to, well, basically we leave it to as it is, which is -1 in the first place. If we enter a negative number, then parameter 1 is also set to -1, and we use that -1 later on for validation reasons. So if we go back to turn left, so yeah, there we have that, and we use this valid command boolean to validate if the command basically, if it's a valid command or not. So if we type something different, that's what or typo when we're typing the command, it will unvalid the command, and then we'll get a message for that, which we'll see later on. So turn left is work. Basically, we didn't show that, did we? So turn left. So just use the left actually, and the turtle turns left by 90 degrees because we didn't use any parameter for that. Turn left with a parameter. So if we do turn left 90. So in my case is left 90, and then we type forward 100. Delta goes forward by 100 after turning left 90. So that works as well. Turn right command works. So basically it's the same thing as the turn left. Code's absolutely identical. If we say right without a parameter, we're saying missing parameter, default right called, and if we say so that's okay. If we say right with a parameter, so right 90, turtle turns 90 degrees again, and if we say forward 100, and we go forward again by 100, so that works as well. PenUp command working, type PenUp, and then turn right 90 and forward 100. Right, we can do that, but I think it might be better if we start from the beginning, because the reason for that is reset, because my about method, which we used before that, is doing something different, and the position of the turtle is not where it was supposed to be. So if we say turn right, in this case right, and then where are we now? Sorry, PenUp. So PenUp, pen is up, the image has changed as well, and then turn right 90. So right 90, there we go. Forward 100, forward 100. I don't think we'll get that end shape because we didn't start from the proper position, but at least we'll have the commands in sequence. Right, I think we've missed this point. I'll go back to this one. So we did this one now, but if we reset it again, come on, reset, and if we do the TurnRight 90, so right 90 and then forward 100. Yeah, I don't think we'll get the end because we've missed the rest of the sequence commands. Right, anyways, these are all working, so we'll just continue. Back command working, black command working, which is basically setting the pen color to black. In my case, because I'm using colors for background as well, so I'm using pen black. So let me just show it in the codes. Go back to pen. So here we are. So if we have pen, then as parameter 2 we put black. We're setting basically this. Then we're setting the pen to black, and if we say pen black and get pen is black, okay. So now if we say forward 100, and then we draw in black, so that works. Green command, so again pen green, pen is green, forward up. I'll use 50 because I won't have enough space if I use 100. So the green's working. Red, so pen red, pen is red, so again forward 50 and start drawing in red. White, we've seen that, but we'll demonstrate it again. So pen white is white, and again forward 50 and we're drawing in white. Clear command working, showing your code. So the clear command is very interesting because we've got some additional functions for that, but here it is. So we're validating the clear or the new as well, because looking at the assignment, the new keyword should also do the same thing. So there's only one parameter, so we're updating the screen. So basically we have a Boolean screen update, which is helping us for when we're saving or loading the screen to validate if the screen has been saved before we try to clear it, because we get a message, warning message, which we'll see now. So if we type clear, because we didn't save the image before that, we get this warning, unsaved work, graphics not saved, we should, if we want to clear it. So if we click no, it will not clear it, and it's still not saved. So if we say clear again, it will come up again. If we say cancel, still not clearing it. But if we say yes, it will clear the image, and it hasn't been saved. And also we can see here the message that the buffer update was called, which is another method, this one, which we'll explain later on, which is an addition to the program. So the clear works. Reset command working. So type right, then for 100, so line is drawn, then type reset. The turtle should return to the central position pointing down. Because we're right at the far left corner pointing left, we just use the backward instead of forward. So the pen is down, as we can see, so we say backward 100, okay. And then if we say reset, so if we say reset, it goes in the middle and it's pointing down, and the pen is down again as well. So that works. Didn't say it to show it in the codes, so we carry on. Requirement 3, validation, reports invalid commands, type X into reports invalid command, showing your code. Right, so validation is happening, basically it's happening here, and in the beginning of this method. So here we're validating, well, we're basically checking if the parameters are integers or strings, and we also use the Boolean valid command. So we'll highlight it just to see where it is. So normally when the method gets called, every time the method is called, this boolean valid command is set to true, and then we're checking against each of these command lists for these words. And if we go right at the end of this if else ladder, if you want to call it, we have a method here that's called sorry, not in the method, we have a additional if statement after the if else and the else if ladder of validations, which I just commented as like a final way for which is setting. So basically, after we've been checking all these commands, if none of them is true, the final else of this else if is setting the valid command to false, because if we've checked all those and none of them was executed, you know, went inside these block of codes for the else ifs, then the last one is saying when none of them is valid, so the command's not valid, setting that to false. And then we have another if statement, which is saying when, in this case, if the command is false, run this message here, run this this block of code, which is throwing this message. And we're also having a new window popping up, which we'll see now. So if we type x's, and we get this error message, which we're pressing OK to continue, invalid command. So that is working. Detect valid command with missing parameter. So if we just type forward, we get missing parameter as well. So the method is working, but we just get that message as well. So that's working. Showing your code. I think we've done that. We showed it. So basically, every method that is expecting a parameter as an integer is having this functionality. If the parameter is not an integer, to report it as either missing parameter or so like in this case, if we just have one string, we get that message here. Continuing, detects non-numeric parameter. So if we type forward with x's, so again, invalid non-numeric parameter. So this is happening again. These validation extra validations here that I've got. So we get that message. So if we have a forward and the array then is, so if we put more than one parameter, we're still going to get that message. If we have two parameters here, but the parameter one is a negative number, remember from the beginning, parameter one can only have a negative number if that parameter is not an integer here, the way we've shown it from the try and catch statement. So that's okay. Bounce parameter, for example, you can show that you can't move the turtle off screen. So if we say, for example, forward 300, if you take it, because 300 is a normal parameter for this type of you know, sizes, but it goes outside of bounds here, and we see the console saying out of bounds, and the turtle is set back to its maximum position here for the x, so for the y. So if we type forward, let's say 1000, we say an excessively large number input. So anything bigger than need to see what was the number. I think it's that, yeah. It's been declared as excessively large number because there is no reason why we should enter a number anything higher than that, 999. So the bounds working, saving and loading. Save command works to save an image, draw something. Okay, showing your code. So if we go to save, where is this? So save file image. There we go. So if we type save image, this case. We're calling this image save method, which all the methods that I have additionally made are in the other class graphics system. So if we go now to this class and we find the method image save, there it is. So this is what we're doing. We're using the buffer image. We're creating an object of the buffered image class, and then we are saving that to this file name turtleimage.png, which is directly into our project folder. So if we type in, so let's draw something first. So let's clear and reset the turtle, and we say forward 100, then left 40 degrees, and then forward 50, and then left 45, forward 50, and then left 80, and then forward something really random, 50 again, and then left 60, let's say 90, and then forward 200. Right, so if we want to save that, we can do it in two ways. One is to use the save image command, and two, we can use this button that I've made, extra button here. This button will only save the image, it will not save the commands in text. So let's use the save image command first. So if we go now to the project file, folder, we see this file created just now, and it's a PNG file, so we can open it basically with paint and we can draw over it. And if we now go back and if we clear this, well, let me just first follow the script. So the saving is working, and we've shown the code. Now load command works, clear the screen. Okay, so let's clear it. And if we, again, we can either use this load method or the load command. So load image, and we get the image loaded again. And the code for that is this here. So we're using, again, buffered image class, and then we're trying to create that buffered image from the file we just saved before that. So we need to have that file, otherwise we get an exception. And then we update that boolean, setting it to false, so we don't get, now if we clear, we won't get that warning that we saw before, because the image is now was saved. We have that as saved, so there's nothing to lose now. And if we put the pen up and we move it around, so let's say forward 50, forward 100, let's say, it doesn't matter. Oh, sorry, pens. So again, try that clear, get the warning message because that wasn't saved. But now we cleared it, and we put the pen up. Okay, so the pen's up. If we just move the turtle forward 100, it's not drawing because the pen's up. Now if we try to clear it, we won't get that message because we didn't change the image. It was the way it was before we, after we've cleared it previous time. So there's nothing to lose. That's why it's not asking us now. So it will warn us only if we draw something. So now if we put the pen down again, and go backward, so now we've drawn something. So if we try to clear it, now we get that message. Okay, continue. So the load's working. Save all commands previously typed as text file, show in your code. So the save commands command is calling then the file save method, which is image load command save. There we go. So we're saving them to this text file. Again, we're using try and catch statements in case something's wrong with the file. And we're using the TurnRight class in this case. And we're using the S buffer, which we created. I think, let's see here. It's actually a string buffer that we create, and it's created as like a public in this class, so we can use it in the commands as well, because we use it here as well to help with the clear. So if let's now try to draw something and then try to save the code. Now there's like an extra function that I've made for this, and let's just reset it. Turtle. Right, pen's down now. So if we type forward and then left and then forward, let's say 300. So the interesting thing now is if we go left 33, right. So we've drawn something, and look what happens now. We want to clear this, and yes, we didn't save it, so we'll clear it. Now the buffer has been updated, all these commands and everything. So we start from now. The buffer starts creating a history of the command from now on. So look at the turtle, its position and the angle of it. So this has also been saved in our save file. So if we type now forward 20 and then left 150 and then we say forward 350 and then we say right 59 and then we say forward 200. So we end up in completely different position and different angle. So now we save the commands that we've typed. So we press so save image, save commands. So we can use the save commands command. So the commands now have been saved, and if we go to the project folder, we see now this file has been created. If you open it, look how it starts. It starts with setting the previous parameters and this new extra method that I've created, so it can restore the turtle's position and angle and start drawing whatever I've done before. So to show that, we're now going to clear this. So look where the turtle ended and the angle. So now if we clear this, we can either leave it like that, or even if we reset it, it doesn't matter. If we now, let's just go back to the script. So the save command works, we saw that. Now if we try to load the text file, what's going to happen is the turtle will first come back to its original position and angle. So load commands, and then we'll start draw the same thing, so we end up with the same image. So that is thanks to this extra method that I've created called set where is it? Set direction, I believe it was. Yeah. Command custom color font right at the bottom. Set direction. There we go. So this is how we've done it. What it does is it's taking the turtle's direction before we start drawing, after we've cleared the graphics, and then it works out, and that works even if the turtle has been left if the turtle started from a negative angle like it was here. It's basically inverting it into, it's working it out the direction that it's got to set it in positive numbers. So it's really interesting, but it works really nice. So the loading is working as well. don't know if we've showed it in the code. Save buffer, slightly higher. So command save, command load. So yeah, this is the way we've done the loading command. There we go. So we're using that file again, creating an object of class file, and then we use the file reading as well, and we read basically a line at a time of this file using the string buffer as well. Yeah. So a warning is displayed somewhere in console or a dialog box. I think we've shown that, and the current image is not saved. So yeah, so if we didn't save this image now, if we try to clear it, we get this warning. But if we don't clear it, so it's still not saved. If we save the image like we've shown, we can do it from this button, image saved, and now if we clear it, we don't get that dialog box with warning. So this is the new image that we saved again, and we can also show that the load button is working by pressing it, and we get that image back, image loaded, says here. Let's get that help again. So a warning display using GUI dialog box, yes, we just showed that. Right, the kind of inheritance. Override the about methods. So here is my overridden about methods. Just have to find it because where is it? So in the beginning, wasting so much time for that. Overriding the about method. Yeah. So here's what we do. So first, I'm setting the color to dark gray, so we can see even if something is drawn in black. Then we're clearing the image, and then we're calling the super about method, which is the original about method for LBUGraphics. And then on top of that, I run this method, my name, which is drawing my name, which we saw from that method, and then displaying my name as well. So if we just call it again, so we're clearing the image and starts drawing it, and then we'll see when we finish with the original drawing, it's going to continue with my name, and then we'll send the turtle in this corner. There we go. So this method, my name, there is it. It's using other methods, which we have a separate method for drawing each letter. So we've got the capital T, the small o, and so on. And then it's drawing a circle and ending up in this corner. And then each of these letters are here. So we've got the small r, and then we've got the small d, and then we've got the small o, and then we've got the capital T. So we can create as many as we want from that. And the interesting thing is that we can change the size of this, basically like a font, by passing a different integer number to this. Right, so let's continue implementing a square with a parameter. So if we go to square, there is it. Square, we have this default square without a parameter using a default value of 20. So we can just clear this and reset the turtle. So if we just type square, this is the default one, and we also get this square missing parameter message here. But we can also type square with a parameter, which is square, let's say 30, and it will draw a bigger one with 30 pixels. So that's by calling, well, basically it's the same thing, just doing different validation. There we have this one, and the square method itself, well, how is it doing is we're using for loop for that. Easy with a for loop because the square is very easy to draw. If we find it, anytime soon. Drawing a square. Right, there we go. So we're doing some extra validation here just to make sure we're not going out of bounds. That's what this if is for here. And if we're getting too close, we use bigger parameters. We're saying that we can't draw a square of this size because it's getting too close and it will go out of border. So it will not even try, it will not even start drawing it. We'll show it now. So otherwise it will just do this, execute this for loop, and it will just draw the square. So basically if we say square 70, can't draw a square of this size, you know, it's too close, you get beyond this border here. So that is working. Pen red, green, blue parameter. So we get here, we've got the command pen color with RGB integers. So if we say pen color 5, 200 to 50, let's say. So custom pen color set, and if we just type forward 100, okay, pen is up, so we need to drop the pen down. So let's go backward 100. There we go, nice blue custom color. And the way we're doing this, so pen, where is it? Pen color, there we go. So if we got the pen color, and if we have 3 more parameters and they're all integers, so there's a validation for that again, which we showed in the beginning. And if those are valid integers, then we run this code, which is basically calling this method setPenColor, passing those parameters. But they're actually calling this method as well, which is my custom method, which we'll see now, creating a color, basically Java color, and then passing it to the setPenColor method. And this method, my color, is somewhere here. If we find it, would have helped if we had all these hidden instead of have them all opened. Anyways, too late now. Saturation, right, where is it? PenDown, draw image, the reset, override, triangle, square, drawing a letters. Oh my god, there we go. So this is the method that is taking 3 integers, and it's an object of the color class, Java color class, and then we are passing this as a color object, and then we're taking that from this method, and that's how we do it. And we've done the same thing basically with background as well, so we can set custom background colors. So this is an extra that I've done, it's not from the assignment, but so we've shown that, we've shown the code. Penwidth, so if we say penwidth, if we say 5, and then we go forward to draw something, okay, forward 100, so it's slightly wider, right? But if we say pen with 11, we can't accept that because pen width can be a parameter between 1 and 10 only, so it doesn't work with any number higher than that. So that's working, showing the codes. Okay, so pen state, pen stroke, pen width, there we go. So this is how we've done it. It only accepts to basically to have a parameter, pen width plus a parameter, and it's got to be an integer. So basically if it's 0 or a negative number, if it's a negative number, it means it is not an integer, so it will not execute for that. We get an invalid parameter message displayed, and then this is the case where it shows that message if we type in value different than that. So that's working. Then triangle size, triangle with a parameter. Again, here we can see we got just a triangle with parameter, and triangle with 3 parameters. So if we say triangle 28, for example, oh, that's too close, it will not draw it. Hold on, we need to reset it. Reset. Let's just set penwidth to, let's put 2, and we say triangle, let's say 28. There we go. Triangle with 28 pixels. So where's that? It's just here. So triangle, if we have 2 parameter, basically 1 parameter as an integer, and it's taking that as a parameter, as an argument for this triangle method, which is basically the method I've done here. I think we're using a for loop again, drawing letters. Okay, square a triangle with 1 parameter. There we go. Yeah, we're using for loop again to draw the triangle with 60 degrees. So basically we're using a multiplier, by the way, for the length. So that works for the triangle. So if we use 2, let's say triangle 20, 34, and 40, and then it will draw custom made. Let's clear this. So it's triangle 20, 34, and 40. So there we go. Draws a nice triangle, and that's triangle with 3 parameters. This is the code for that. Again, we're doing some validations in case if it's too close to the border, and this is where we call it. See if it's 4, if we have 3 parameters basically. So that works. And the extra things that we've done, if we go back to the main class, here's the comments with all the extra things I've done. So added user interface field to the right side, so this here, which displays different information about me, about the help button, displays all the commands so you don't have to remember how they're spelled and how you have to format them. Then the save button for an image, the load button for an image, and the close button which closes the program as well. Then the so these buttons here is another extra. Close commands for information and color, and the save image and the load image. And then we have the PenUp and down image, the real-time update indicator here that we've shown that is working. So PenDown, PenUp, PenDown. Here we go. And we have the align method to align the turtle in the nearest straight angle. That's something we didn't show yet. So the align method, where is it? Align the turtle, there we go. So this is how we've done it. And basically it's what it does is, if our turtle, let's say we put it left to 4 degrees, so it's not completely at a 90 degree, but we want it to be. So instead of figuring out what's the angle now and then calculating how much we need to change it to be right at a 90 degree, all we can do is just type align, and the turtle goes straight at 90 degrees. So even if we are at a different angle, so let's say we put left 137, so we're at a funny angle now, completely lost. So if we say align, it will just go to the nearest 90 degrees. So depending if it passes the 45 or not. If it's exactly at 45, so if we say left 45, so now it's at a 45, it's at a diagonal now, perfect diagonal. And if we try align, it will say, well, you are diagonally, no alignment necessary. But if we go by 1 degree, let's go 1 degree to the left, and now if we try to align, it will go further left to the nearest 90 degree. So this is how it works, and it's really helpful when you try to, draw perfect lines, straight lines. Then the custom background color option. So yeah, we talked about that. So it's not just the pen that we can set a custom color, we can also set the background. Basically it's the same principle, we're using the same method, so there's no point showing it again, but it's just something that wasn't asked, and I've done that as well, because I thought it might be something really good to have. And created method set direction that has an important role when saving and loading commands, which we've shown that how and why it is working, why is it so helpful, because without it, for example, you start drawing something when your turtle is all the way to the right and it's pointing at a funny angle, and then you finish your drawing in completely opposite corner and completely opposite angle, and then if you load the commands, they will not do the same thing because you're starting from a different point and your angle is completely different, but you start drawing the exact same commands. So in order to overcome this problem, I've created this method, and it's really helpful and it does a really good job. And we've shown it previously in the code, but let's just have a look at it again. The set direction, I think it was at the bottom. Yeah, set direction, there we go. This is very helpful, very useful method, really. So, and it's working, like I said, both for positive and negative you know, directions of the turtle. So if we say, is it direction? Yeah, it's at -180 now, but we can set it to if we imagine the positive, so -180 basically is positive 180. So if we add extra 90 degrees to point up instead of pointing left, so that's 270 degrees. If we want it there, we just say set direction to 270, and the turtle will go at that position. But if we type direction again, it will still be negative. It's at -90, but we are exactly where we want, so that's how it works. Really cool feature. One other thing I've missed to show is it doesn't matter how we spell the words. So if we say capital F, small o, capital R, and then forward, this will still work. It doesn't matter how words are spelled. We can do all capitals,